So in the last class we had discussed, we actually stopped at importing. So we had done text files, yes, and what was the function that we had used to read text files? It's read dot table, a generic function which takes data path as input, separator, header. Those are three inputs what we had given, and then we had imported that file. Excel files, how did we import?
Read Excel.
Yes, read underscore EXEL, right? Read underscore Excel from read Excel package. SAS7BDAT, it's read dot SAS7BDAT. Have we done this? We haven't done this, right? Okay. Did we or did we not do this? We did it, right? Importing SAS7BDAT file. Online guys, could you please confirm? Yes, chalo. Read dot SAS7BDAT from SAS7BDAT package. Connecting to DBMS, did we connect? Yes. I had used our MySQL. Yes or no? We did, right? I have used our MySQL package because this is not made up of just one function. There are a lot of steps what we have to do, which is common for every DBMS. Establish connection by specifying all the like user ID and all. We have to first establish connection between R and the DBMS. Then we can send some commands like fetching metadata. What are the tables? What are the table names? What are the column names and stuff? Third is send queries and fetch results. Fetch results. So finally, if we are trying to import any data, we used to send this select star query, right? So that we used to get the entire table from the DBMS as a data frame into R. Same process applies to any kind of DBMS. I don't have Oracle with me. I don't have any licensed Oracle version with me. So I'm not able to show you that. Our MySQL is basically an open source software, so I was able to show it. Fact of the matter is that it's same in each and every package. You don't have to worry about it. XML, I have XML package and I have a function straightforward which is XML to data frame. That's the package. That's the function from XML package. It converts an XML file into a data frame accordingly. Creating a data frame from vectors. We had taken vectors of equal length. They can be combined to a single data frame using data.frame function. So it takes equal sized vectors. We didn't do it. We didn't do it, right? All right, then we'll do the final last thing. How to create a data frame from vectors. We'll do that in a short while. Any questions in these cases? Text file to XML files. Did you guys try importing anything? Okay. So at least you are able to import Excel and CSV into R, which is the basic starting point of your data analysis, right? Okay. Again, as a caution note, must be noticing that R will be taking Linux style file paths. Same what we have used in folders, my folders, in University Edition. You'll have to use the forward slashes. People working on normal SAS, day-to-day SAS can accept any kind of paths. Whether it is backward slash, forward slash, SAS will accept everything. Windows style, Linux style, everything it will accept. But R will accept only the forward slashes in your path name. If you are copying it from the Windows, make sure that, because Windows uses backslash, make sure you just put double backslash. We'll add one more backslash. that creates a proper escape sequence. So you will have a good file name, or use /. Now today what we will do is, we'll anyways create data frame from vectors. We will start from creating an R project, so that we have a very organized structure of saving things, right? So please pay attention to this. So if I happen to, I'll just create one more tab here before I go to deep into data frames. I'll call this as R project. So you have to navigate to file and then click on new project. This is my step one. So file, new project. So what you have to do, and if I do that, okay, first things first, it will ask me whether to save the workspace image or not. I'll click on save. Now here I get three options: new directory, existing directory, or version control. So I would obviously select new directory. So after I click on file, new project, I'll get a pop-up in which I'll select new directory. So this is the hierarchy. First I'll click on file and new project, and then I'll get a pop-up and I'll select new directory, obviously. Now I have three more options. Should I go for an empty project, or create an R project, R package, or a Shiny project? You all know what R Shiny is, right? R Shiny is the front end logic. Like you will write R codes which get converted into front end. So I will click on empty project, of course. So here I'll be selecting, I'll be going ahead with empty project. And once I click on this, I'll get another pop-up in which I can specify my directory name. So specify directory name, directory for projects. That's it. I'll just save. Let's say this is Feb batch. I'll put it as Feb batch, right? So I'll save it. Now before I click on new project, before I click on create project, please look at it here. I have something called open in new session, right? So if I tick mark on this, so the existing session, whatever you're seeing on my screen here, the RStudio, the existing session remains as it is. A new window of RStudio will open. This session will not be closed. And if I don't do that, if I don't select it, it will open by closing the previous session or previous project, right? So I'll click on open in new session just for creating sake. And second thing you must notice is this tilde sign here. This tilde sign has a meaning. So what is the default directory in R? My documents, right? So this is the default directory of R. So a tilde represents my documents. A tilde will always represent path to my documents folder. So it can be anything. This is my system. So this is my system. The path to my documents is this. Just a second. So this is the part to my documents. My username is admin. So it's C users admin. You may have a different name, right? So this is being represented by a tilde. So the path that you're seeing here, is almost equivalent. Like if I happen to write it in tilde, the equivalent to that is this tilde / station.txt. That's the meaning of the tilde operator. Got it? Any questions online, guys? Firstly, am I audible? Because I am not able to speak a little bit louder. Like I am not able to speak louder. So I hope this is fine, right? Okay. What is there to explain in this?
Just we need to save it. That's it.
No. Whenever you are using, like, see, station.txt is present in my documents. You know? So the path to my documents is this: C uses admin documents. So instead of writing all those, I can simply use a tilde character. A tilde will always point to your my documents folder. This is by default. By default, tilde will always point to my documents. So if you want to access, let's say I keep accessing datasets folder in my documents, right? So I can do like this. I can put tilde hyphen datasets. See, it is appearing automatically once I press the tab. Then I can select any of those like stores.csv instead of writing the full path. So if an Excel sheet is present in my documents folder, you can use tilde / Excel file. Yes, any questions there?
Like our data is saved in my folders and that stuff. So
so your data is, so you have to write the full path in that case. In that case, you have to write. This is what I'm telling. Like, please listen to the class carefully. Like, if your data is in my documents folder, then my documents folder can be accessed using tilde. No other folder can be accessed using that. This is what I think I was trying to tell you that, if I'm not wrong, right? Okay. Okay, moving on. So it's file, a new project, don't save, new directory, empty project. So my directory name. So please look at it, what it has written. Create project as a subdirectory of tilde, which means my things are now getting saved in this particular thing. Let us say, as just a part of your work, you are just trying to redo the SAS assignment 1 in R. So you must have created a folder in my folders, right? Let's say in D drive you have created SAS University Edition. You had my folders. Inside that you have that folder where you have done your case study 1, right? So you can just change that path. So you have to browse and go to that place. So I don't use SAS for all obvious reasons. So I'll just go and locate to that place where my SAS University Edition or that files are present. So it's almost like manually selecting your lib name without any writing any function, because there is no function as such. So you'll be creating project in that particular folder. Now this all ritual is because you have to have proper organized and sequenced way of putting your folder. That's more mature, right? You're doing a project, it has to be organized and well arranged. So this is why we are doing this. So I'll put my directory name as let's say febbatch in my documents. So I'll just create a project. So it will be switching to a new project. So everything is plain now. So if you can just look at the top left corner here, it's tilde for my documents / febbatch. And you'll also notice that a folder called febbatch would have been created in my documents folder. Where was it? Here we go. Oh yes, over here. Right? That's it. Did we talk about saving the global environment, working directory and stuff? We didn't, right? Not an issue. Okay. Any questions still here? Classroom and online, guys? Now, online guys, just tell me, what do you mean by lib name in SAS? Yeah, guys, what is lib name in SAS?
just a location.
Just a location.
That's a reference.
A reference to?
A
reference to a physical part. Okay. See, SAS system and R both need memory to work upon, and data needs storage to be stored. R uses your physical memory, that's RAM. SAS works on virtual memory, but they need some memory to get their clocks done, cycles done. So in that case, they need at least a reference pointer that should locate to a particular file location in the physical storage, so that accessing files for them would be much easier. They can access it without having to go for more number of cycles. So in SAS, what you have libname, in R I have a concept of working directory. So any folder can be set as WD. I'll be referring to it as WD, a working directory. Any folder can be set as working directory, right? So all inputs and outputs, it can be fetched and saved in the working directory. The last benches are able to see the text here, right? Clear, right? Or should I zoom in? It's not required, right? Last guy. Fine, chalo. Now, in a project, so no guesses, the project folder is the working directory. Is the working directory, of course, right? In a project folder becomes the working directory. Most of the class guys are sleepy. What's up? Need coffee? Should I order coffee for you guys? No, right? Wake up, please. Because if you're yawning, automatically I'll start to yawn. That's contagious, actually. No, actually, it's seriously contagious. I started to feel sleepy for the last 5 minutes. Okay. All right. Now, to check the working directory, the function is getWD. GetWD checks for the working directory. Online guys, are you following the class? Fantastic. Now, given the outside conditions and given the internal comforts of your home, I am really skeptical. Like, I keep losing track. If you guys don't respond, I will have to assume that either the connection is lost or you are asleep. So please confirm. Okay, so getWD will get the present working directory. So I said for a project, the current or the default, the working directory would be the project folder. Thanks for that assurance, Anurag. Now, you can set any folder can be set as working directory. How to set working directory? I have a function called setWD. Somebody said R was difficult. So setWD, just put on the path. That's it. Now, one last thing before we do, let's go on and create some objects. Few simple objects. So x is equals to 10, S1 is equals to R class, V1 is equals to 1 to 10. What else we had? We had V2, let's say, and call it as sample what? Sample letters, and randomly sample me 10 letters. Replace is equals to true, and that's V2, and so on. So we have few objects here. Let's also import some data frame. So it stores a read.table or read.csv. It's a till for my documents, datasets, stores.csv, and that's it. So we have few things in the global environment now, right? We are doing it and all that stuff. Now to get list of all objects in global environment, I have a function called ls. So we are talking about our projects here. So till now we had done this. We had created a new project. Working directory is the project path, right? That's the default working directory, project path. But anyways, we have two functions like setwd and getwd. Now we are talking about a global environment. So to list all the objects, list all objects, so I have a function called ls. So ls gives me a list of all objects. If I run this, I will get a vector. So you can see all the object names here. Any questions till now, online guys? Online guys, any questions? See, that's why I become skeptical of you people. See, okay, that's fine. I know there would be a lag in the broadcast. There would be a little bit of lag in the broadcast, so I have to wait. Okay, yes, this is similar to Linux. ls gives me a list of all files and folders. So here in our ls function will give me a list of all objects. Now, you might have heard about this function called rm, right? rm object name will remove an object. So if I say rmx, it will remove x. What if I combine both? Remove function and list all objects. What will happen? Remove all objects, yes? So yes, so rm list is equals to ls will remove all objects, right? Should we do that? Let's do it. Done. So your environment is empty, right? So we have a situation here. Situation is that like you deleted objects which you actually needed. There's no way how I can get it back right now. Yes or no? There's no way that I can get them back now. So before removing objects, it's always advisable to store the objects. Yeah, you have to store the objects first, right? R works on RAM. If you're creating a variable called X, it's there in your RAM. This now, sir, it's there in RAM. So is S1, so is V1, so is V2, so is stores. Everything is there in RAM, not in your physical storage. Because R works on RAM, not on virtual memory. So we have to store the objects in the physical file system. That's what I meant by store the objects. So objects needs to be stored in physical file system. Right? Purpose can be anything, mostly as a backup. Right? To do it, I have a very simple thing. Please notice it here. I'm trying to close RStudio. What is the message that it gives? Save workspace image to .r data file. So this is the catch here. So the file extension, all objects and their information can be saved to a .r data file. That's it. So I have a function save.image. I have this function save.image in which I'll put the file name, right? Let's say today is 15th April 2017. I'll put a timestamp. It's almost 2:30, right? So 14:34, right? Dot R data. Clear with this? Why have I done that? So I am just creating a file name and using save.image. I'll save it. Where this will get saved? My documents. Online, guys. Where this file will get saved? Where will this file get saved? Exactly. That's the answer I was expecting. The project folder. Yes, we are in the project folder now. That's my working directory now, right? So get saved in the working directory or project folder. So I'll just run this. That's it. Done. So if you can look over here, I have this .r data file created in my system, right? So that's what that is. So list all objects, LE, save all objects. It's save.image. Now, I'm just removing all the objects. So if I can remove, like if I can save all objects, I can also fetch them back, right? Fetch the objects back. Why you want to do this process? What's the dire necessity of it? See, taking backups is always advisable. Let's say you're operating on your data and by mistake you have done something that has fiddled around, that has just manipulated your data in a very wrong way. Because you have kept backup, because you are smart enough to keep backup, you can just roll back. If people who are familiar working with DBMS, we have something called rollback and commit and checkpoints, save points. So this is an equivalent of that concept in R. Right? So I'll create some checkpoints. I'll create something like on a day-to-day basis, on an hourly basis, I'll just create these backups and keep it in my storage. And once my day is done, I'll delete this and I'll take a daily backup of my entire day. So the next day, I'll when I start fresh, I can just go back to where I had left. Right? Now, how do I fetch the object back? To do that, I have a function called load. All I have to do is load the file name. So the file name here is 15th April 2017 1434.r data. Look at the global environment. I have them back. Once I execute the statement at line 41, I get all the data back at the global environment. Cool, right? Any questions online, guys? Okay. So here finally I have load objects. The function is load and remove. It's rm. Remove all. It's rm list is equals to ls. That's it. What's the question? Save.image is storing all the objects defined till the statement. Exactly. Save.image will save all the objects, not at the, it cannot be measured in number of lines or which statement it is. It is measured by time. Let's say it is 2:38. At 2:38 you are running the statement. It will save all the objects that you have created till 2:38 p.m. on a particular day. This is what it means. So if you happen to write it in between lines, yes, of course, Sarita is right. In between lines, whatever objects were there, they get saved in that. Okay. Any further questions? I'll be waiting for that. Any further questions? Please let me know. Yes, of course, yes. Timestamp has to be defined exclusively, and it all depends upon your organization's requirements. It also depends. It's highly specific to the work that you're trying to do. I mean, I can't generalize that. We can't say that this particular thing has to be done in this particular way. It has to be. It depends on the situation. Any further questions, online and classroom guys? Okay. That was all about R project and your global environment. I hope this is one of the most important parts of R. I just made a point of covering this before we go further. So that whenever you are working, I sincerely feel that your work should be more organized than just spread across. Now is giving me character 0. Anjali, which function is giving you character 0?
LS.
Is it ls function? So it's giving, do you have any objects in your environment? How many objects do you have in your global environment? You have all the variables. So I think that will happen, that situation will happen only if you have no variables in the global environment. Let's say I have deleted all these and then I had run ls, that should give me character 0. If I have any variables, that wouldn't give me character 0. Please check it once. Anyhow, next up we'll be moving to the data frames, more of the deep data frames topic. Now, this is something you're going to answer me. So if I have a data frame, what all we can do? What are the tasks that we can do? Like, let's begin from a very basic task. What things we can do as a part of data manipulation, or what tasks? I mean, like, I should reframe these questions. What tasks you have done in SAS as a part of your data manipulation? Stuff. That's again a little bit advanced. Append, merge. Okay, that's the most recent topic of yours in SAS. So append, merge, and before that I have sort. Okay, what else? Filtering, sorting. Okay, filtering, subsetting, creating new variables. Fantastic. Creating variables. Yes, somebody said formatting. So formatting in R is like, we don't have a concept of formatting in R, but what we can do is change, work around with data types, change data types, creating variables, change data types. So to create variables, you need to extract variables as well, right? So extracting variables. What else we can do? Can I change the column name? I can change my column name, right? So renaming a column. Formatting, done. Creating new variables, filtering, sorting, checking for missing values. Fantastic. Excellent, actually. Filtering, subsetting, sorting. Before we go to append and merge, let's remove remove missings. And if I have the dire necessity of removing missings, I should also remove duplicates. No dupe. Stupid things. In SAS. Shading missing values, labeling. Labeling is again SAS related stuff. Of course, we'll not do it. Output, yes, excellent, Amit, but that like it comes in the end. It's like the end credits what gets played. So it's exporting. What else we can do? Is that it? Like, aren't we missing anything? No, it won't happen in R. That's more of your excellence aspect, not in R. What else, classroom guys? Tell me, or else I'll just turn off the AC. You guys are so sleepy today. Deleting columns, fantastic. If there is a marriage, there has to be a divorce, so deleting columns. Oh, just kidding. Like it's no offense meant to anyone. This is an era of being politically correct. So you can throw stones, but get tied to vehicles. That's human rights violation. Did the correct thing actually. Again, my personal opinions doesn't reflect the country's one. We are wrong in every step. So join and merge, they are one and the same thing. Bad man. That's for your BA classes. Extracting, renaming, relating, changing data types, creating variables, filtering, subsetting, sorting, removing missings, remove duplicates, appending, merging. Right? Or shall I not do it? Should do it, right? What else? Drop and keep as in? So that's subsetting. That comes under subsetting. No, sir, no. There's no order by. Through loops is not a part of this. It's not a part of your data wrangling. And loops is a word which should not be used in R. And it's like Voldemort to your Harry Potter universe. You should not use the word loops in R. We have different things for that. Come on. Anything else we can do onto your data? No, again, reporting is your graph stuff, not in this. Macros? No. Functions, sir? No. Arrays, everything. See, Dhruv, Mr. Dhruv, have you heard about an invention called vector in R? This is what arrays is, right? Please don't go back to the square one, for God's sake. Anyways, yes, this is pretty much the things that you can do onto your data. This what we call it as data wrangling. Data wrangling with R, or data manipulation using R, the most respectful term. So let's start by, what I'll do is, I will be using this stores dataset as an example. I would be using the stores dataset as an example to show you a lot of stuff over here. So here we go, we have imported stores. This is just a sample data which mimics some retail information. It's a retail data basically, where I have some store codes that represent a unique code for each and every store. I have 32 stores, so I have 32 unique codes for each and every store. I have store name. This is the name of the brand. This is the brand name of that particular store. I have store type. So I have three categories of store type, like three categories of it. So electronics, apparel, and supermarket, spread across 4 locations: Delhi, Chennai, Kolkata, and Mumbai. And for each and everything, we have a lot of metrics here, like operating cost, the total cost incurred to run that business at that particular location, that's operating cost, number of people working there, staff count, total sales in thousands, so 160,000 as in 1,60,000. So it's showing total sales. I don't know on which basis, yearly or monthly. Total customers is the monthly customer count, right? Acquisition cost per customer, number of amount spent to get a customer into your store, which doesn't make much of difference here in this case. So what are the important variables here is operating cost, staff count, total sales, total customers. I have something called profit per customer. This is also an important metrics here. So operating cost, staff count, total sales, total customer acquisition, total customers, profit per customer. These are some of the continuous variables present in my data. Some of the variables that gives me some or the other kind of count metrics present in my data. I have categorical variables like store name, store type. Sorry, categorical variables as in store type, location. I have this variable called own store. 1 if it is, if the premises are the own, or 0 if it is rented. Online presence, do they have an e-commerce site? 1, yes, 0, no. And store segment, I have 4 random segments here. I don't know on what basis they have arranged it, but these are the overall description of this data, right? So I'll be using this data here. Now, first things first, describing the data. So whatever I have told you verbally, let's try to find it out using a function. So I have this function called structure or str. Str object name, that is stores. Structure function will give me a list of all variables present in my system. So just notice this, first 4 textual variables are factors here, alright? I've said that I'll be explaining factors once we get into the data part. So here we are facing factors. Look at the rest of the things. They're either numeric or integer, but mostly they are numbers from operating cost till store segment. Any questions so far? Okay. I have another function called summary. It gives me very basic summary statistics of my data. Very basic summary statistics. So please look at the output here. So for every categorical variable or for every textual variable, it is giving me a frequency count, a frequency table. So my total count is 32 rows I have, out of which there are 12 apparel, 8 electronics and 12 supermarkets. Or look at the location column, out of 32 elements I have 8 each from every location. So this gives me a frequency table. Now look at the numerical columns here. If I just consider total sales, so it is giving a 5-number summary here. 5-number summary along with arithmetic mean. The 5-number summary is this: 0 percentile, first quadrant, 25 percentile, median or 50 percentile, third quadrant, 75 and 100 percentile or max. This is the 5-number summary. Along with it we have mean, the arithmetic mean. So it's I mean, like, if I have this kind of a 5-number summary, it's always easier for me to have, just imagine a curve of distribution. So a kind of a curve can be imagined, so if I say 71 to 472, this is what it represents. and my mean is almost closer, like median, my mean is 230.7, so it's almost around here. So 230.7 would be almost across the midpoint. I'm so sorry, I'm not so good at drawing. So I can find out how my variance lies, where my variance lies, right? This is useful in that. Embarrassing paintings, but I'm so sorry, bear with me. So that's about my summary function. To get even more robust summary statistics, I have a package called Psych. I'll just load it. I'll go ahead and load that. A Psych package. In Psych package, I have a function called describe. So I'll run the statement here, line 55, describe stores. It's also quite similar, but it gives me more outputs compared with the 5 number or 6 metrics of summary function. It gives me a lot of metrics here. N for frequency, mean, standard deviation, median, trimmed mean, mean actual deviation, min, max, range, skewness, kurtosis, standard error. Now, if people who have no idea what these things, what does these things mean, especially like given the fact that some of you must have been listening to this for the first time, the significance of these metrics, you will know it in your first BA class. Why these things are highly essential for me to know. Why it is highly essential for a person to know about your data first. Why it is highly essential to know what is the variance of your data. It's highly essential. So we'll be knowing all those things in our first BA class. Till then we have to wait. Keep on the suspense rolling. Here I'm here just to teach you these functions. So that's what your describe function does. Okay, so next, now let's get into columns. So what we were discussing in this sheet, let's try to do all these tasks here. So we'll begin with extracting variables. Now to extract variables, $sign is used. $sign is used to extract variables. So if I just happen to write stores, $, as soon as I put $, you can see the pop-up which contains all the column names. So let's say I'll pick up location. So $sign will extract the contents of the location column. I'll just print this on the console. I'll print this thing on the console. Can tell me which data structure is this? Which data structure is this? It's a vector, right? So what's the moral of the story? $sign is used to extract variables. What data structure it extracts? A vector. A vector will be extracted from a dollar operator. A data frame or a table is a collection of equal sized vectors. Of course, right, if I just slice my data frame, if I remove all the 15 columns of my stores, it It almost means that I have 15 equal sized vectors clubbed together. This is what is a data frame is. So every operation that we had discussed on vectors can be implemented to this.
Sir,
Yes, sir.
where is this stores file?
Pardon?
Where we will get this stores file?
So stores is I'm extracting it from my documents folder.
My documents. So
Yes.
This is being already saved there.
Yeah, it is already saved there. I'm just reading it into my R system. So we had discussed importing, right, in the last class. So this is what I have done. I've used read.table to import it, right? Okay. So I'll just go ahead and save it in a variable. So location is equals to store.location. Can you make me the presenter? I lose my job. So next step. Renaming, deleting, creating. Didn't we miss one thing? Change data types. Yes. Sahil dollar is used to extract a column as a vector. Okay. Next up, changing data types. So how do you get a data type of a particular variable or particular object? Class function. Class function. So if I have x is equals to 10, class of x gives me the type. That's what we have learned before. Now what if we pass that to a vector? So let's say I have a vector v1 1 to 10. So class of v1 gives me the data type. Problem here is class of stores, because stores is a heterogeneous data structure, you can't get the data type so directly, right? It won't come, obviously, like, because it's a combination of multiple data types. What it should give you, it can't, right? Instead, here in this case, line number 70, when I'm passing a heterogeneous data structure, it gives you the data structure. It says that class is a data.frame. The object is data.frame type. It gives me the data structure of it, not the data type. Now, let us extend this to a column. So what if I say class stores dollar location? Now stores dollar location is a vector, right? Now this will give me the output, because by default data is getting imported as factors. So a textual data location is a factor. Any questions online, guys? Any questions? Now this is how you get the data types of each and every column, or you can just directly use the str function. Str function gives me the structure, so you can also get the data types over there, right? Now, how do I change it? Again, if I have x, which is a number, if I say as dot character x, it gives me the contents as string. And if I do x is equals to as dot character x, it converts x into character, and again it saves it back to x. So here we go. So x, before the first stage it was numeric, now it has become a string, a character, because I have changed it. Let's apply the same logic here to location. Class of location here, the first run, line number 80 here, it's a factor. So location is a factor. I just want to change it to character. So all I can do is as dot character stores dollar location. So that should change it to character type. Now will it get saved? Now this line here as of now at line number 83 is not permanent. Will convert and print. Of course, no change in the original data. This is what we had learned before also, right? Yes or no? So how do I save it? It's all simple. So I'll say stores dollar location, line number 86 is equals to as.character stores dollar location. So this will convert and save. Changes made to the original data. I hope you got the difference. Yes. And let's run this and see it. Stores, str stores. So look at it. We have changed location to character here, right? So this is how you would be changing the data types. And changing data types is especially helpful in dates. Why? Dates are by default characters in R. So change the data type. Change it to date type by specifying appropriate formats. Of course, right? We have done all those things. How to change your date types and all stuff. Any questions so far? I'm speaking a little bit low. I hope online guys are able to comprehend and understand. Okay. Now, I think I should die. R, SAS, well, this bloody battles. Okay. So that was changing data types. Let's add some variables to our stores, shall we? Now, notice it. I'll call it as adding variables. Now, if dollar can extract out elements, dollar can also be used to add variables. So if I use stores dollar, some name which doesn't exist, let's say new column, I'll just put something like random info. See, a column of a data frame has to be a vector. It has to be a group of elements. So if I'm passing something, it has to be a group of elements, right? But here I'm just passing one value, one single value, and I'm trying to add it as a column. What will happen? Let's see. So if I run the statement in line number 96, you see that in stores, I'll have a column created at the end, appended at the back. So all the 32 elements will have this text called random info. So dollar, this is how we use to add a new variable. If I say stores dollar, if I give blank, so it will add a new column. It will not have any value in it. It will be of character type because I have given a double quotes, which is basically, it's not called white space. I know what it's called. Let's call it as blank. Let's add one more sensible column. Let's say here I have total sales, total customers. So this example I keep giving. Let's add a new variable according to the logic that add a new variable grand total sales by multiplying total sales and total customer. Add a new column called grand total sales by multiplying total sales and total customers. So let's do it. Total sales is stores dollar total sales. So we need a one-on-one adding, right? So vectors, two vectors can be added one-on-one. If I say V1 multiplied by V2, each and every element, corresponding elements will be added or multiplied or whatever operation that is. So if I say total sales multiplied by stores dollar total customers. So there will be one-on-one multiplication. Total sales first element multiplied with total customers first element, so on till 32 elements. Now this needs to be stored in grand total sales. So the grand total sales is equals to stores total sales total customers. Something missing? Stores dollar over where? Excellent. So this will create a vector. As of now, line number 102 will create a vector called grand total sales and not add the thing to your data frame. So to have this effect, so I have to do stores dollar. Stores dollar grand total sales is equals to stores dollar total sales multiplied by stores dollar total customers. Any questions in this? No, right? Online guys, any questions? So if I do it, I have stores dollar grand total sales here. Clear with this? This is how you add your columns. Which brings to me one more action which you guys had actually missed. I'll tell you what. Now you see, adding column using any method, columns get appended. Columns get appended as after the last existing column, or they get appended to the rightmost part, right? That's not something which I need, right? I need not first, but I need these columns to be added at appropriate places, right? Columns need to be added at appropriate places. How do we do that? Now this is where your dollar operator is not so useful. So dollar operator is not so useful here because it can't do it. How do I do it? What's the thing? What's the other thing that we are left with for subsetting? Pardon? In SAS. R is not SAS. What function? What is one more golden thing that we have in R which can be used for subsetting? We have used that in vectors. We have used that in every place, and we have forgotten it now.
Providing conditions.
Inside of what? Oh, guys, the square brackets. Index brackets or square brackets. Yes, right. We have one, right? So here we go. Enter square brackets for data frames. So let's see how square brackets can be useful for our data frame. Square brackets for data frame work on this principle R comma C, or I'll call it ROW comma COLOUMN, rows comma columns. So it works on this principle, rows, comma, columns. Now to extract columns, let's first stick to columns at this stage because we are talking about columns. Let's stick to columns. We can get into rows in the next part subsequently. To extract columns, can anyone say how to extract first column? Let's say extract column number 4. How do we do that? Online guys, can anyone answer this question? How do you extract column number 4 using square brackets? Stores, square brackets, 4? No, it should be comma 4. Pardon? 0 is not required, just leave it blank. 0 is a non-existent row, so it will give an error. There's no row called 0th row, right? So it will give an error. If I'm leaving it blank, it means that there is nothing selection, nothing much thing going on in the rows part. It's only columns part. So stores, comma 4 will give me a vector of that particular column, fourth column. Fourth column happens to be location, so it gives me location vector. Advantage of square brackets. So dollar can extract only one column at a given instance, but the square brackets can go for multiple columns as such, right? So if you want to extract columns 4, 5, 6. So yes, using C function, yes, you can use the square brackets and this. So I can say stores, square brackets. First of all, I'll put the comma. Am I applying on rows or am I applying on columns? Columns, right? So I'll stick to the right hand part of the comma and I'll say C 4, 5, 6. What data structure this will give me? Vector. Vector or 3 vectors? 3 vectors. Combination of 3 vectors or just individually 3 vectors? Combination of 3 vectors, and combination of n vectors is a data frame. So output of this statement here at line 122 is a data frame, a sub data frame, a subset of the main data frame. So here we go. On the console you can see, yes, this is giving me a sub data frame, right? Any questions online guys? All right, so this is columns 4, 5 and 6 that I have extracted. Now how many of you know counting? Counting. You know counting, right? You can count from 1 to 15, right? Okay. Randomly tell numbers from 1 to 15. It has to be from 1 to 15. Randomly tell some numbers. My favorite number? 10. Okay. 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 7 is done. 5. 8, 15. Yeah, go on. Pardon? 3. Just a second. Just a second. 1 second. Just hold on 1 second. .csv. Just please hold on. I'll have to re-import this. And yeah, so it has 16 columns right now, stores. Yeah, 16 variables. Yeah, go on. 3, 5 is done, yes.
4 for 6.
4 is done, no. 4, 6. Online guys, we can also count, right? 11.
14.
Yes. 16. Do we have all numbers from 1 to 16 covered? Look at it. Confirm that, online guys. Yes or no? I'll just save it in an object. I'll call it as stores2. Right? The same 32 observations of 16 variables. What happened? Columns got jumbled up, right? So Oxford Dictionary calls it as a rearrangement of columns. Yeah, 300 years ago, while they were writing this dictionary, they knew that in an analytics lab there would be a batch sitting there. They would be doing this process, so they named it as rearrangement of columns. Now let's do something sensible. I have stores, and I created something called grand total sales, and I don't want it appended at the end of it. I want it in an appropriate position, which is, logically speaking, it's just besides total sales and total customers. It should be somewhere over there, or at least in the middle of it, right? Total customers is 8th column, and this is 16th column. So I need 16th column to be 9th column. So grand total sales is 16th column, and I want it as to be replaced 9th column. So to get it done, call it as stores is equals to stores square brackets comma C, right? 1 to 8, they remain as it is, right? Column 1 to column 8, they remain as it is, they won't change. Here comes the change. 16th comes here, 16th column would come here, then 9 to 15. I mean, at least, like, this is what is the logic for this statement. Overall, the crux of the story is, in your subset part, in your column subset part, keep jumbling, keep writing any kind of order that you need. You'll get your new data set in that order. Your columns will be in that order. Now here what I'm doing, I need 16th column to be the 9th column of my data set. So I said, according to that logic, if I go 1 to 8 happens to be my first 8 columns, 16th column now becomes 9th column, and 9 to 15 are as it is. I'm just pasting that. Now if I run the statement, look at this. Now this is nothing of a rocket science thing, but the 16th column has now become your 9th column, right? Any questions in this classroom, guys? Any questions, online guys? Okay. See? Combine operator. Combine function. Fantastic. Yes, excellent, Nilesh. Excellent. Good question. So Nilesh asks, can we pass column names to that instead of just writing the indexes? Yes, of course we can. So by passing names to square brackets, yes, we can do it. Let's say I want to extract location, just one column. I can say stores square brackets comma, because I have to do for rows and columns, within quotes location. So that should give me a vector of locations here, right? Or if I say stores comma, combine operator, store code, location, grand total sales. That's it. Well, it's almost subsetting it. Of course, column will not, the column operator, the what do you call, sequencing operator will not be valid in this case. Of course, it will not be. Now, let's talk about renaming a column. Acha, in R, you have some inbuilt variables. These all are inbuilt variables, like something called letters, which gives you English letters in lowercase. This will give you uppercase letters. Of course, there is nothing called numbers, for God's sake. I have month dot name, right, which is your month dot abbreviation. This I had discovered recently, so just I'm showing it off. I never knew that this thing existed before. Okay, what I'll do just for sample, let me just create a vector to show find and replace operation. We have already done this, but let me create a vector. Some 10 letters randomly I'll extract. So V4 has PRTIOSUDGA. This is all happening randomly. These are the contents. Let's say I want to look for, so these are my contents. I'll just print it over here. Now, next time if you run this, it will be something different, of course, right? Sampling is always random. At this instance, this is what I have. Now, let's say I want this T replaced by a star. I want T replaced by a star. Now, how do I do that? Go on. V4. Seriously?
Yes.
No? Sir, how do I look out for T and replace it? Yes. Guys, V4 equal to T. Did you forget this? Yes? We did that, right? On last Saturday's class. How do you find and replace stuff on a vector? Right? Okay. I'll have to take this matter to the Supreme Court, man. Seriously. So this is how you find an object. If I just happen to assign star to this statement here, line number 147 that you are seeing now, means look out for V4, the object element called T, replace it with star, right? This is what this thing means. So if I happen to run this statement now at line 147, look at the contents of V4. It encountered T in this position and it got replaced with star. Clear this? Online guys, any questions in that statement there? No, apart from Sonam, Amit, Nilesh or Harshit, Sarita, others. Rohit, it not only replaced it, but it also stored it. Look at the original contents of V4 now. V4 has now changed. T has been replaced with star. Now, look at it. Let's apply this logic to column names as well now, right? Now, to extract column names, the function that I have to use is names. Names function will extract all the column names. So if I say names of stores, this will give me the vector, a character vector containing all the column names, right? Now, if this is a vector, let's say I want to change the name of your thing here, staff CNT. Let's say I want to change staff CNT to number of EMP. Staff underscore CNT, I want to change it to number of EMP. What should I do? I should have to do the same vector operation that we have done, right? So first look for staff underscore count. Where do I have to look at? In names of stores, right? Names of stores is a vector. I have to look for staff underscore count. How do I do it? How do I do it? Names stores equal to staff underscore CNT. Seriously? Square brackets? Guys, first of all, wake up. Please. Oh, that fan is also on. That's nice. That's so sweet. Okay, first of all, again look at the statement here at line 147. Right? Take the vector, use square brackets, then look out for it. Here my vector is names of stores. So I can't do this, line number 150. This will just give me true or false. Now pass this to the square bracket notation for names of stores. Not everything needs to be accessed by a name, right? You can access it by the function as well. Not every time your class teacher calls you by your name, right? They can call you anything. They do that, right? Buggers. So that's what we are doing now. Names of stores, I'll use the square bracket and then look out for staff count. What it does, it will extract the variable called staff count. Yes? Now my next step is replace it with number of EMP, right? This is what we are trying to do, right? And how do I do it? Same step here. Names of stores is equals to staff underscore count. Assign what? Yes, number of EMP. Done? Yes? Let's go back to stores now. Look at it. Here. Renaming in R is perhaps the only thing which is not about any function, but it's about the logic that we are trying to do. There's no direct function for this in the base packages. The idea here is get a vector of names vector of column names, find the thing that you are trying to replace, and then replace it with a suitable name that you are looking for. This is what I have done in 3 steps, right? Now, before we just close and go on for break, I wish to cover the same things, the same rename and adding columns using dplyr. Let's try to do that using dplyr. So what am I doing? That's why I don't want my students to yawn in the class, because I'll feel sleepy. So here we go, adding column. See, dplyr is a package which contains some functions, straightforward. The best part of dplyr is that functions are easy, number one, and not just the functions are easy, not just the syntaxes that are easy, but also the names are also easier. I mean, any data manipulation task that you think of, the functions which are there in dplyr, they're very much easier to remember. They're much closer to the verb. It's not like, complicated square brackets and stuff. So let's see that. Adding a column is done using mutate function. Mutate, what does mutate mean in English? Just change the form, right? So mutate will add a new column. So let's do the grand total sales example again using mutate function. So we can just copy those stuff here. Here we go. So here we are. Right. This is what we have done in base package. So let's see how to get it done using mutate. So I'll say mutate. This is the function from dplyr. The syntax is first thing that I need is, of course, the data which I'm applying on. Second, to n new columns that we are adding. Right? And the syntax for that second argument is somewhat like this. Column name is equals to vector. This is somewhat the rough syntax of it. I'll show you that. So I'll say mutate stores. Now simple. I don't have to use any dollar operator or anything, that stuff. You can simply say grand total sales. I'll just call it grand total sales underscore D, so that I can just distinctly identify myself that D is from dplyr. So I'll say total sales multiplied by total underscore customers. Total underscore customers, yes. Right? Let's say we'll also add one more column in stores. Let's say I have operating cost. I'll say total operating cost is equals to operating cost plus acquisition cost per customer multiplied by number of employees. Let's say I'm just using a logic. I'll just write it down here. Total operating cost. I'll just call it net operating cost. Let's say net operating cost is equals to operating cost plus acquisition cost per customer whole multiplied with total number of employees. We had renamed that column, right? What is it? Number of EMP. This is what it is, right? If I just check with names of stores, So yes, new operating cost is equals to operating cost plus ACQ cost per customer. I'll just copy the exact spelling. And this is number of EMP. Online guys, can you able to hear me? Okay. Okay. So this is my formula. So yeah, there was some lag. Yes, I can get it. So using mutate, what I can do, the advantage of mutate is that I can add multiple columns at a go. So I'll also be adding this here. I'll also be adding this logic here. So I'll call it as net operating cost. Not new operating cost, it is net operating cost is equals to the formula. Clear? Right? Now finally I'll just save it to my stores dataset. Or let's say I'll call it as stores underscore dplayer D for dplayer. That should create a new dataset. So if I just run the statement here, it creates stores underscore D. 2 more columns have been added to my original dataset, right? So look at it. In the end, this is also adding it to the end. There is no way how I can specify the column position. So here we go, grand total sales and new operating cost, net operating cost that has been added using mutate function. Any questions in this? Any questions online guys on this mutate function? Next, what follows is your rearrangement. This should follow up by rearrangement, putting that column name at appropriate place. Coming to renaming variable, it's also simple. I have a function called rename. Let us say in my stores dataset, I want to change location here to city. The variable name called location, I just want to change it to city, C-I-T-Y. First tell me the base R method. Rename location to city. Can anyone tell me the base method? Yes, Parisha, by mutate we can add columns. Yeah, can anyone explain me the rename, the base method for rename? Names, stores, square bracket, names, stores, equal to location, assign it to city. Easy, right? You know what is more easier? Rename function. Great. Claps for him. So rename stores, comma. Look at the thing here, syntax here. So it's in the form of new name is equals to existing name. Existing name is location, new name is city, right? Oh, I'm so sorry. I have to save it to stores dataset, right? Stores, rename, city is equals to location. You can go for multiple renames in one statement. If I run this, look at the stores now. Location has been named to city. Any questions? Right? Clear with this? Base was a little difficult here. Rename is a little bit easier, right? Believe it or not, there exists one more easier way. Well, like R is one peculiar language which avoids using easier ways. It wants your life to be miserable. No, just kidding. There is a function called fix. So if I go for fix stores, it will open a pop-up. Do whatever you want. And like I won't be stopping you. Change city to location Change the data types, do whatever you want, man. I'll not stop you. I'll change grand total sales to character. Just close this and open stores back. We'll have everything back. So city change to location, grand total sales here is character. Fixed function it is. Use it with caution. Now at this stage what I'm doing is, again I'm re-importing the stores dataset for my convenience. I'm just resetting it back to my original form. By using fixed function, of course. So grand total sales is supposed to be numeric, for God's sake. No fix is in base package, sir. So fix is in base package. So what all things we have done till now here? So we extracted variables, we renamed it, we deleted the column, changed data types, created new variables. Done. Let's take a break. Of course, we have to take a break till 4. I'll come back and discuss the remaining stuff, right? So 3:46 it is. We'll come back at 4. Okay. Again, I repeat. So to delete a column, I can use $operator, which can extract, add, and also delete a column. All I have to do is, let's say I have considered stores underscore D. I'll use this $operator, the column name. So if I assign null to that column name, it gets deleted. So once I had executed this, look at it, stores underscore D, which had 18 before. Now the net operating cost from the end has been deleted. That's how you delete it. Now till here we had discussed, so these things we are done with. So till here we had discussed everything which were mostly acting upon columns. Our main criteria, our main question here was columns. So now let's just work upon data. Let's try to do stuff on the data part. Now just listen to this logic. If I have a student table, no-wise columns are a very good way of organizing my data. But if I have a student column and let's say I want to look at a particular roll number, let's say roll number 10, for instance. The data for that particular roll number 10 is present row-wise, right? Data is always present row-wise. So if I look at roll number 10, the person's name, gender, the classroom, marks, score, every detail of that student is available row-wise. So when I talk about data, I talk rows. SQL, if you have worked with any DBMS, if you run any query, you'll get the output. Finally, it says that number of rows selected, 10 rows selected. So rows contains data, right? What is that? Pardon? Sorry. So I thought we have this blow horns for the blow horns for IPL, what we use it, the air horns. Okay. So subsetting, filtering, sorting, trimming, find and replace, binning and encoding, duplicates, merge, binding, group by. Everything has to be done row-wise or on the data. We are now started to act upon data. So let's discuss each and every step here. Command Shift to another chair. Yeah, Amit, I'll discuss that in the end. Now, subsetting a data set we have already done, right? Using square brackets, we can subset the data. So let's say select first 5 columns. How would you do it? So sub1, let's say we're just creating an object sub1, stores, yes, comma, 1 column 5. That's it. First 5 columns are selected. Or you can also say stores, comma, C, 1, 2, 3, 4, 5. That's it. First 5 columns are selected. So first 10 rows of the 2 given columns. How can we do that? Yes, go on. Sub2, stores. Online guys, I hope you have a keyboard, you can type it. Please send me the answer. I'll just see, let's match it or not. Online guys. How do I do this here? The question in line number 209. Please let me know that. Okay. Correct answer, Nilesh. So stores 1 to 10 for first 10 rows, comma. Now go for the column C, location and store type. That's it. So sub 2 will have first 10 observations from location and store type subset. Now filtering. Filtering is basically applying conditions to the data. If I'm not wrong, filtering is applying conditions to your data. So conditions to the data, which means they mostly should go to the rows part. Despite the fact that we are mentioning the column names, but data is spread across the rows of a particular table. So we have to look for rows. That means we have to write the conditions on the rows part. So here we go. Let's say select all rows where location is Chennai. So to do this, let's call it as subset 3. So it says stores dollar location equal to Chennai, right? Is this correct? No, this is not correct. I should add a comma because this happens to be in the rows part of it, right? Not on the columns part. So I have to put a comma here. Now look at sub 3. 8 observations of 16 variable where every factor in the location is Chennai. Right? H dash subsetted based on a condition. So we have filtered our data based on a conditions. Any questions on this online guys? Good. Multiple conditions can be separated using any of those logical operators. So let's say you need to select all rows from Chennai and Kolkata. That's simple. I'll call this as sub 4. So store's dollar location is equals to Chennai, and just besides it I'll put an AND condition. Of course, so store's dollar location equal to Kolkata within quotes, right? That's it. No, I think I have. Sorry, or condition. Sorry. So if it is either Chennai or Kolkata, just give me that. Select all rows from Kolkata where total sales greater than 200. Easy, right? I mentally compare this with your SAS syntaxes. This looks immature, but it's much easier to understand and implement, and this is also faster compared to SAS. Not just given fact that it works on RAM, but also the code complex, the algorithms complexity is very less. It works very fast compared to SAS. So store's location is Kolkata, and store's total sales is greater than 200. That's it. So I'm so sorry. Called the sub 5. So here we go. I have 3 observations. All the 3 are from Kolkata where total sales are greater than 200. So I have 400, 351 and 301. Any questions so far on this filtering? How do we select, let's say, first 10 rows with location Chennai? First 10 rows with location Chennai. So that's where we are stuck. Good question. And that's where we are stuck. We can't do that directly. Let's say Chennai here, let's say in this example, this is what Arjit is asking. Look at line number 217, please. Sub 3 is giving me 8 observations of 16 variables when I am subsetting with respect to Chennai. Let's say we need first 3 elements here. First 3 elements of that subset. But this cannot be done in a single line. This cannot be done in a single line. I have to do a subsequent step. So I can say required subset by Arijit, so that we can remember afterwards. So that's sub 3, 1 comma 3 comma 1 colon 3 comma. So first 3 rows. So this is required subset by Arijit. Right? Clear this, might? Did you get it, Arjit? That's cool.
Can we apply ascending and descending?
I'll tell that, of course. When we go for sorting, we'll do that. Yeah, that makes more sense, right? Arrange in descending order and take first 3 observations. So we'll discuss that eventually. Don't worry about it. 1 NC?
1 second.
Okay. Okay. I just went blank. What is 1 NC? Okay. Okay, Rohit, I'll explain that. See, Rohit, look at line number 217. That is subsetting sub 3. What we are getting here is from the main data set, we are extracting all the rows where location is Chennai. Now, there is a condition here. Let's say you need to extract that subset where your location is Chennai, but You don't need all the rows. Let's say you need first 3 rows of the subset where location is Chennai. So this step here, this question here at line number 219, it cannot be done in one single step. So your first step would be running subset statement where you are extracting location Chennai, and then you have to do a further subsetting where you are getting first 3 rows. Is it clear now, Rohit? Okay. Already we are sleepy. Somebody is playing a lullaby. So, seriously. Suppose we have final output, but we have created too many objects to get the output. In R, we need to remember which object to delete. Oh, yes. That would be a straightforward answer, yes. Alrighty then. Now, okay. Regarding subsetting and filtering, we have a base, one of the base package function called subset. So this is from the base or inbuilt packages of R. So subset function does the same thing what the square brackets is doing. So let's say if we I'll just put up a question. Select all rows from Kolkata where total sales is greater than 200 and keep columns location and total sales. The question is, select all rows from Kolkata where total sales is greater than 200 and keep columns, location and total sales, not all the columns. So that can be done using subset function. Now, how can we do this question here in base package? It's stores. Yeah, go on. Stores dollar location is Kolkata and stores total sales is greater than 200, comma, C location, comma, total sales. Okay. So that can be done using subset function somewhat like this. Please look at it. Subset stores. Now the advantage of these functions is that I don't have to use dollar operator time and again. So I can simply say subset stores where location is equals to Kolkata. And I don't need dollar sign every time, like I said. So I'll just remove stores dollar thing. Location Kolkata, total sales greater than 200. And then select part. The third part is select part, where I'll say select 2 columns, that is location and total sales. That's it. So select is equals to location and total sales. That's it. So subset stores, location is equals to Kolkata, total sales greater than 200. Select location and total sales. That's it. So I'll just call this as sub underscore subset function. Means this particular object is coming from subset function. So we have 3 observations of 2 variables, Kolkata and total sales. Any questions in subset function? I think with this information you can just fiddle around each and every possibility that comes across you. Clear this? Everyone? Online guys, any questions? Okay. How many of you online and classroom, how many of you are familiar with SQL? Good. Considerable amount of people. Online guys, who else is acquainted with SQL? That's so many of you. That's so nice to hear. Let's go back to all the examples again. Let's take only one example. Let's take the last example, what we have done with subset function. Help me writing a SQL query for this, please. Online guys especially, help me writing a SQL query for this. Select location, comma, total sales from stores where see the cases SQL is case insensitive, so it can be small letters as well, but I'm more acquainted with this kind of thing. So yeah, so where location is equals to, or location like Kolkata, right? No, who's that? It can be. And total sales greater than 200. Total sales greater than 200, right? Where location, okay, for your thing, within quotes, Kolkata, and total sales greater than 200. Observe two things here, please. The words location, total sales, stores, Kolkata, everything I have used from the data frame. The exact spellings, right? Yeah, thank you, Rohit. Yes. Outside I have used a double quote. So inside if I required any double quotes, or inside if I required any quotes, I'm using single quote. Right? Any questions in this query? Non-SQL people? Any questions? Now I'll just save it in an object. I'll call it as SQL underscore Q or SQL query. I'll just save it as an object, which is a string object, right? Now why am I doing this? Because in R I have a function, I have a package called SQLDF. Loosely stands for SQL data frame. In SQLDF package, I have SQLDF function. So if I happen to pass this query string, which I have stored it in SQL underscore query, to SQLDF function, okay. So it will execute that query and give me the results. So I have selected location, total sales, where location is Kolkata and total sales greater than 200. That's it. The query gets executed. So write your SQL queries, execute it. Clear with this? Right? So SQL guys can now pretend that they know R with SQLDF package. And like learning SAS in the first stage was a little bit hectic. Since the day, so this is an era of being politically correct. So okay, 1 second. All right. So subsetting filtering is done. Let me know any further questions. Yes, there are two functions from dplyr package which does the task. It's slice and filter. Slice and filter function from dplyr does the same thing. It's your task to find out how. Figure it out. How to use slice and filter function from dplyr. So you have the R help, are manual available. So you can slice and filter the data set using it. Let's go for sorting your data. Online and classroom guys, just remind me one thing. Did we discuss order and rank function? Oh, thank God. Okay. Amit, Ayush. Yes, we did discuss rank and order. We did, right? Amit and Ayush. Detention. You face detention after this class. 1 second, you're not in the class, right? So if I have a vector of elements, okay, not V1. So let's take a vector. I've taken V2. Have some random numbers here from 1 to 100. So if I just sort it, so sort is an operation which is highly applicable only for vectors. So I can sort, going by that logic, I can sort a single column. So if I take location, or let's take, if I take store name for instance, I can sort store name, yes. No, this is in alphabetical order. The result that you're getting here, this is in alphabetical order. I can't use sort function to sort my entire data set. No, I can't do that. That's the thing where sort function fails. I need to go for a function which gives me positions. And what better is that than order function? If you remember, if I just use order function here, order of V2. So this is the sort of V2. This is V2 in the first place, and this is order of V2. It gives me the row numbers. Corresponding to 34, I have 9. Why is that? Is it corresponding to 34 that I have 9?
26.
Exactly.
26.
9, if you look at 26 here in the sorted vector, what was the original position of 26? 9. 26 was in 9th position, so I have 9 here. Next up is 31. What's the position of 31 in the original vector? 2. So that's why I have 2. 34's original position? 1. So I have order of 34 as 1. 39 position? 8th position before. So I have order as 8. I hope you got the order function now, right? Amit and Ayush. I hope it rings a bell. Okay. Smart move, Amit. So now let me extend this order function to the square bracket notation. So if I take V2 square brackets order of V2, what do you get it? You're getting the sorted vector, right? Yes? And let's extend this to the data frame, right? I will have few scenarios. Let's just sort by one text column, sort by one numeric column, reverse, sort by 2 columns, sort by 2 columns, one in reverse. I sort by 2 columns, one of them will be reverse. Let's say sort by 2 columns both in reverse, and let's finally will come to sort by 2 columns, one in reverse, one in normal. Right? Okay. Sort by one textual column. Let's say we are sorting by location. It's simple. I'll take stores. I'll find out the order of the vector location. So I'll say stores order stores dollar location. That's it. Now tell me, this should be in columns part or rows part, because I'll be sorting my data. Which part should be? It should be in the rows part, right? So I'll put it before the comma, or I'll put comma after writing this. Stores order stores dollar location comma. I'll just call it as sort 1. Fine. If you run the statement sort 1 here, look at the column location. So it has been rearranged based on alphabetical order of location. C comes first, followed by D, K and M. Clear this? This is arranging by one column, and also look at the way how which the row numbers have been jumbled up. Right? The row numbers here, extreme left corner of the table. Just before the table has begun, we have row numbers, right? When this has also been jumbled. So which means our data has been actually rearranged or sorted. Now let's see other one. I'll call it as sort 2. Sort by one numeric column reverse. Let's take total sales. So I'll say sort 1, or I'll just call this sort 2. Stores order stores dollar total sales comma. Right? Now, what addition should I add to my order function? Reverse is equals to true? Means something like that, huh? What is the option for order function to go for reverse order? Not descending. Decreasing. Decreasing. So within order function, I'll say decreasing is equals to true. So order function will now give total sales arranged in decreasing order, the order of that total sales vector. Now if I execute this statement sort 2, I hope you are just noticing the syntax. Sort 2 here, and I have total sales rearranged. This is the maximum value that can go for total sales, and if I happen to scroll down, see 71.1 is the minimum amount. Right, so this has been sorted. Any questions? Online guys, any questions in line number 265? Now how do I sort by two columns? No. Not everything is combinations. So see, order function can be overloaded. Multiple options can be used for order function. So if I give something like this, please pay attention. Please pay attention over here for order function. Comma, stores dollar total sales. Stores dollar location, comma, stores dollar total sales, and I'll put a comma here. Look at it now. Stores 3. If I look at this, location is first being sorted, and within location you can find total sales also being sorted. So row number 9 here is Chennai location, least total sales of Chennai. Keep scrolling down. The very last occurrence of Chennai, what we have here, will be the max total sales for Chennai. So first it is sorting location, and within location it is sorting total sales. Right? Any questions in this? Or any questions in the syntax that I have used? Nothing, this is just a syntax. Online guys, do you need anything to ask? Do you need any clarifications on this? Do I need to explain again? Hello? Rohit, coming to that. But what about others? Apart from Amit, I see the graph of number of people awake is decreasing gradually. Online guys. Okay, so keep responding, or else I'll just assume that you are snoozing. Okay. So Delhi High Court has decided like from the government, it will be rewarding all those people who are active online and analytics labs classes. Yes, it has decided. Come on, like it mailed me actually. I'm not kidding. It also made me, like, somebody also mailed me that I had won Nigerian lottery for 20 crores. These are weird, right? I mean, like, they're not that fools. I mean, like, you can understand that this is fake. So one day my mom calls me up and she was like, she actually started this. So it became a joke around my family that the son won Nigerian lottery. So every time I meet my cousins, they call me a Nigerian king or Nigerian drug lord or something. Who won a lottery worth billions? Or maybe married the king's daughter or something. It didn't happen. Alright. Sort two columns both in reverse. Not a big deal. It's a sort 4. Order. All I have to do is put decreasing is equals to true. Now here comes the big deal now. So sort 1, sort 2, sort 3 and sort 4 are straightforward. I hope it's done with. We're done with this. And here comes the big deal. Sort 2 columns, 1 in reverse. Now here is where this all fails. Cannot be done using order. Now if you have a situation like this, like Rohit asked, sort location alphabetically and sort total sales in reverse. Now total sales is a numeric variable. So this can be sorted. This can very well be sorted. So I'll just copy this code here from sort 3. I'll call it as sort 5. Now please look at this. Stores location I need in ascending order. Total sales in descending. So if I just add a minus sign here, this will arrange total sales in descending order and location goes in alphabetic order. So look at sort 5 now, for example. So location is being sorted alphabetically because Chennai is coming first. But if you look at total sales, the max total sales appear first. So it is now in reverse order. This is very helpful to see by every city which is the maximum sale. Right? This can be done. So sort 5 can be done. But again, this arrangement fails if you are sorting on two textual columns. Look at this now. Look at this now here. What if I need location in reverse order and total sales in plus order? This literally fails here because minus is not meaningful for factors. So I have an output, but that is not the proper output. That's not a proper output which I'm looking for. Right? So here comes dplyr for rescue. I have to use dplyr functions. So that's it. So whenever I did sorting tasks, I never used the base methods. Never. I never relied upon base methods. Despite being the fact that they are faster, I never relied on base methods because they are not complete in itself. They're complicated and they don't solve my purpose. So right from the beginning, I was using dplyr for sorting. And yes, I think Ayush, right? Amit. Yes, I can use SQL statement. That's not an issue. But problem here is the square bracket notation and order function has its limitation. I can't do it. I can't sort. Every case I can't sort. So you understand now where it is failing, right? Minus sign for a textual column is error. I can't do it. So is it clear for everyone why this fails? Online people, any questions? Now what we'll do is we'll just go back from the point where we began sorting and let's do each and everything using dplyr. So dplyr has a function called arrange. So first example I'll do. So sort1. I'll call it sort1 underscore d. D for dplyr, of course. Look at it. Arrange stores. Stores is the data set. Followed by column name or column names. So stores location. That's it. So this is sort1, which is coming from base package. Sorting location alphabetical order. Sort1 underscore d. This is from dplyr. There is no difference in these two. Any questions on the syntax of sort arrange function? Online people? Online people who are awake? Online people who haven't slept? Fantastic. Do sort2. I call it sort2 underscore d. Please tell me this. Arrange stores. So I want total sales in decreasing order, right? So I'll write total sales. Decreasing is equals to true, right? No. To go for reverse order, please pay attention. For reverse order, use the sub function or function, use sub function called DESC. DESC is a sub function present in dplyr. It has no standalone importance, but it acts as a sub function within arrange function. Please look at it. So I'll say DESC total sales. Any questions on this syntax? Online and classroom people? Online people who are awake and classroom people who are trying their best to be awake. Any questions? Okay. That's it. So if I happen to run this, so total sales is arranged in reverse order. Rest all examples follow. So sort3 underscore d here is much simpler. Arrange stores location total sales. That's it. It will sort by two columns, location and total sales. Sort by two columns both in reverse. So I have to use DESC individually. Please pay attention over here. Line number 280. I'm arranging stores, decreasing order, location and total sales. both should be enclosed within DESC function, both of it. So I'll say DESC location and DESC total sales. And DESC can be applied for any kind of a variable, whether it is textual, non-textual, it can be applied on any variable. Now over here, sort 5, location and total sales in reverse order. Sort 5 underscore D is this, arrange, stores. So location is in ascending order, total sales is in descending order, that's it. Clean, right? So no matter how many columns are there, no matter how many descending columns are there, so for descending just use the keyword DESC and keep on mentioning the column names, that's all. Any questions in sorting? Any questions of any kind in sorting? That's cool. So we have done subsetting, filtering and sorting. We'll just close by doing trimming and then we can stop the class. Yeah? Tomorrow we can continue the rest. Trimming is removing white spaces. Right? Stores, how do you read it? Say read dot table, let's say read dot table file. My file is located in my documents, dataset, stores, .csv. Header is equals to true. Separator is equals to within quotes comma. Strip white is equals to true. Look at this option here. Strip white is equals to true. So this option helps you getting rid of leading and trailing white spaces at the very initial stage. When you're importing data, if you want to ensure that you don't have any white spaces in your data, you have to use strip.white is equals to true. That's it. So when the data gets imported, it doesn't get imported along with the white spaces. Let's say still, even after importing, you forgot to use this option or just imported with white spaces. You can also get rid of it using the function trimws. So trimws gets rid of white spaces, both leading and trailing. Let's take an example. I'll call this name or location. Let's say location. I'll call it as Delhi. I'll just add spaces. Right? I'm starting spaces there. Problem here is this location here. If I use double equal to, if I have to check for Delhi, this will not match. This will of course not match because location has Delhi with 3 spaces before and 3 spaces after. I have to get rid of these spaces always. So to do that, I'll use trimws function. That's a trimws location. So you don't have any spaces on the left and right. So trimws removes white space from both left and right. Right? If you wish to remove only left or only right, I also have options. So I can say trimws location, which option? I can set it to left. It removes white space from left. If I set option which is equals to left, it removes white space from left. Needless to say that. This is my answer here. The left 3 spaces are removed and we are left with Delhi followed by right 3 spaces. So that's not counted as white space, Ishan. The space between two words is not a white space. It's, what is it? Separator? I mean, like, trimming is a process where you remove white spaces before and after the word, not in between. That's a different process. That's string replace. Trimming, straightforward, is removing leading and trailing white spaces. So that's what it means.
So what if the file is tab limited? Still we can use it?
Tab delimited, you have to import it first. See, everything what I'm doing is not on the files. These are on data frames or vectors.
Over there you write on the file only. No?
Which one? This one.
First one. Yeah, here.
So?
The CSV file is, if the file is tab limited,
Can
I use script.py?
Yeah, you can.
Okay, so
Why
it will
not?
Harm importing.
So it will not harm the importing. It will not change the original structure of your file, right? Whatever it does after importing it. Try importing, like that will not affect my tab delimit. See, I'm not using stripped white for the file itself, right? File gets to the R first and then strip.white gets appeared. Yes or no?
That's right.
So file, my original file is not getting changed. I'm not acting upon the file. I'm importing the file. Listen, I'm importing the file. My file is now as a data frame. Then strip.white gets applied. So your white spaces are gone now. Until unless that doesn't come as columns, you can't detect it, right? So first it will come as the data frame and then it gets replaced. Right? Okay. So right here removes white spaces from the right hand side. Any questions? Any questions here? Okay. Just a little bit rewind. I just go back to the very first concepts that we start over here. While we were importing or extracting columns, please pay attention on this. Where did we do that? Here. A table or data frame in R is a collection of equal sized vectors. So trim have different functionality as it has in Excel. I don't know Excel, so I won't be commenting on that. Okay. I mean, like, I use Excel, but I don't know Excel. Like, I don't know what the trim function stand for. So a table in R, a data frame in R, is a collection of equal sized vectors. This is what I've said, right? Now, coming back, yeah. Let's take, I'll call this like vec1, which contains 5 elements. Vec2, I'll say I'll have 1 second. Okay. So vector 2, don't ask me which function is this and all that stuff. Let's say 10. Vec 1 also I'll take 10 elements. Vec 2, random names 10. And name separator is space. Name dot order is first name and last name. Then ask me what this function is, and I'm going to explain that. Vec 3, I have few elements from 1000 to 3000, randomly 10 elements. Right. So here we go. So if I print the contents of Vec 1, I have numbers 1 to 10. Vector 2 will have random names. Magically somehow it appeared. I don't know how. Vec 3 is numbers, randomly some numbers. Now, like I said, data frame is a collection of equal sized vectors. So if I have 3 vectors, I can combine them to form a data frame. So if you have got n equal sized vectors, they can be combined as a data frame, right? So I'll use the function data.frame. Please look at it. I'll call this data from vectors. Please look at the syntax. Data.frame. I can straightforward write vec1, vec2, vec3. That's it. But thing is, I'll just give names before I do it. So I'll say empid, for example, is equals to vec1. Emp name is equals to vec2, and salary esal is equals to vec3. If I run the statement here, data.frame, vector1, vector2, and vector3, straightforward. I'll just give some names. So please look at it. It creates a data frame. Majida habit. Okay. So this gives a data frame of vectors. So 3 vectors, I combined it to form one data frame. Any questions in this? Online guys, any questions? Good. So yes, I have used a package called random names as a function called random names, which will generate names randomly from any ethnicity. You can just specify the ethnicity and other stuff. And trust me, the Indian names that it generates are actually funny. So one of the most funniest name I came across, no offense to anyone actually, it was like Bal Subramaniam Pandey. I mean, like, you don't have such names in India, for God forbid's sake. So use that function with caution. So these are some of the functions from your text mining and stuff. Okay. Will it give an error if you mention anything? Yes, Sarita. This gives an error if the 3 vectors are not of equal sizes. Let's do the entire ritual where I'll say vector 1. I'll just reduce the size of it. I say 1 to 5. So if I run this, so that should give me an error. I didn't run this. It's creating? I think NAs will be added or repeated. Okay. The values are repeated, which is a logical error, right? It's not a valid thing to do. So it's always equal size vectors which has to be going in. It's not an error, but your data is not proper. It's a logical error, not a syntax error. Any questions? Is it same as we had column with single inputs? I didn't get your question, Amit. Can you please be more clear? You can turn on your mic and speak, please, if you wish to.
Yeah, actually, I just said that it was same as we did it in the initial example where we had specified only one input in the column and it had captured in the whole column for multiple rows. As we started with creating a new column.
No, that was just a subset. That was just a subset.
No. We had created a column, inserted a column name with single input where there were multiple rows. So it gave the same output in every row.
Acha, the random info, that one, right? Yes? Yeah, kind of. Kind of, yes. Can say that, yes. It's explicitly doing it, like it's not in our control. All right then, let's stop here for today.